To learn more about the latest and real-world examples, we have someone from Ecopia's team who has been closely working with cities and local government across the US and Canada to talk about these challenges and how our data could help pave way for solutions. Justin Proctor, hey Justin, is an associate in the public sector team at Ecopia and has been working with clients across the US, such as the City of Detroit, City of Seattle, and City of St. Louis on their stormwater billing, asset management, and other climate resiliency initiatives. Justin went to the Western University in Canada for political science and government and has been with the Ecopia team since March 2022. Welcome, Justin. Thank you for agreeing to do this webinar with us. And thank you for sharing your insights today. And let's kick this webinar off. Over to you.
Awesome. Thank you, Harneet. Thank you, everyone else, for joining in today. I appreciate you guys taking some time out of your afternoons to have a conversation with us. I have an exciting presentation to go through. It's kind of broken down into 3 sections. So we're going to start off talking about the history of Ecopia, where we came from, provide some credibility to the work that we've been doing. And from there, we'll go into a case study with the City of Detroit. And lastly, we'll finish it off with some climate resilience strategies. So although this slide is an animation, it paints a good picture in terms of what we're trying to do, and that's create a digital twin. So this is something a lot of people talk about, huge buzzword in the GIS industry right now, digital twin. A lot of people talk about this, but not everyone is able to actually, talk about it and follow through and create a good product. But this is something that, we like to offer and we like to market, and it is something that, we fulfill. Geospatial data is the foundation of the future, especially this 3D data that we're looking at here. All the layers seen are digital layers, and this is what we're trying to create. So once you have this digital representation of the Earth, a lot of very interesting analytics then become possible. Some of those use cases include determining where to place solar panels on roofs, helping municipal government manage infrastructure, assisting in 5G radio frequency propagation analysis, and supporting property insurance risk assessment. So the history of Ecopia. So the idea for Ecopia was born at the University of Waterloo while conducting PhD research back in 2010. So the focus was on extracting building footprints from aerial or satellite images while maintaining the accuracy of a human. 2015 rolls around, and this is when we take the big step forward as a company and we begin to commercialize our data. So although we are a relatively young company, AI and deep learning at a commercial scale is a young idea or business as well, but we like to look at ourselves as the forefront of this technology. 2016, this is when we achieved our first large win as a company. So Ecopia mapped every building footprint across Australia for the federal government. 2017, or you can see there, about 16 million buildings across 3 million square miles, all done in about 6 months. From there, about 2017 now, as the AI technology evolved and became more efficient, Ecopia was able to grow. A complete map of every building in the US was generated. So 169 million buildings across 3.1 million square miles, all done in about 6 months. So as you can see there, from 2016 to 2017, we were able to 10x our results in terms of those building footprints while maintaining the same area and in the same time period. So it was from here Ecopia transitioned from man-made objects to high accuracy land cover mapping. It was at this point we realized we could tool the same technology for other feature classes, both natural and man-made. 2018 now, the focus is on developing advanced land cover solution, which is used for smart cities, autonomous vehicles, and transportation engineering efforts. So this would be that planimetric level data extraction. While doing these large-scale operations, Ecopia was still able to deliver the data in a very efficient manner while maintaining that high-quality accuracy that everybody desires. And then 2020, these are more present-day initiatives. Also our largest project to date, mapping sub-Saharan Africa, covering 9.3 million square miles, 416 million buildings, 11 million linear miles of roads, all done in about 8 months. So there's many different use cases for these data sets. This use case here is more of a unique one. So this is on the humanitarian side of things. This project was done in partnership with the Bill and Melinda Gates Foundation, and it was used as a data set to provide polio vaccines and kind of plan that distribution. So our goal is to not create data for one customer, but to create data as a commodity that we create once and then tool it for many different users. And by doing this, we create an efficient business model. So these are some of the industries that we like to dabble in. So you got your insurance firms, your telecommunications, government, obviously, civil engineering, and then NGOs as well. So this is just more of a visualization, kind of touching on that history slide. So what you're looking at here is building footprints. So the top left is Australia, bottom left is the United States. Right side there, you've got Sub-Saharan Africa, and then just below that, you have the Italian boot. I like to point out the American one. I just think the US looks cool, how there's a line drawn down the middle, but it just goes to show, how dense the East Coast is compared to the West. So what we're trying to do is create a fit for mapping or a fit for purpose approach. So we want to maximize the utility of a data input to reach the output that is required, being that high precision digital map. We operate on two different functions. So we can either leverage the imagery that you guys might already subscribe to, or if you don't have the most up-to-date imagery, then we can source that for you. We work with some of the larger imagery providers in the game, Nearmap, Hexagon, Vexel. So we have access to their 2023 imagery off the shelf. So we are an AI company, but we're also a geospatial services company that leverages the power of deep learning to extract data from imagery sources. So we recognize the importance of the human input, especially on the quality control side of things. We guarantee that all of our products exceed 90% professional. So we have 3 layers of quality control to ensure that we're hitting that 95%. If the data sets not meet that threshold, it gets fixed and then retrains the model until we're getting that output that we're looking for. So the old saying, fast, cheap, good, pick 2. I'm sure you guys are very familiar with manual digitization, as at some point you've probably taken care of in your career, or you've hired somebody to take care of it all. When it comes to manual digitization, there's a high level of accuracy, generally speaking. The problems begin when you start dealing with large areas and extracting more features. You start to run into interpretation issues as well as those scalability issues. And not to mention, it's very expensive over long periods of time, just paying for those man hours to delineate all those lines. Of course, eCognition would be a great example of one of these. However, they're very difficult to use. They say it takes a PhD to operate these kind of programs. Not user-friendly in the slightest. However, it is a rules-based extraction, so it's able to process large areas at a low cost, but you're not able to get those updates very quickly. So where does Ecopia enter the mix? So Ecopia is creating data sets that are guaranteed to be over 95% accurate. When I say 95% accurate, our data produced is going to be higher quality than what you would have produced through a heads-up digitization approach. The data is normalized as it is a rules-based approach, so you're always going to be getting that consistent output. And we would deliver the data to you in a very fast period of time. We like to say 4 weeks from when we receive imagery, you will receive your data set back. And municipalities struggle with updated, consistent data, and this is something that we can bring to the table. What I was saying here is I just want to kind of stress 3 points from the first few slides, and it's just the accuracy, the scalability, and the currency of our data. So from here, we are going to dive into a case study with the city of Detroit. So the city of Detroit has been leveraging Ecopia's data for just over 3 years now for their stormwater utility fee. Just renewed the relationship for another 3 years at the top of 2023. But we're going to dive into how Detroit leverages this data set. So a little bit of context here. Let's talk about what the challenges are with impervious surfaces. So as urban sprawl increases across the U.S., the challenge for most cities is that their sewage infrastructure has been in place in some cases for over 100 years. So what's happening is we continue to build all this infrastructure above ground without modernizing the infrastructure below ground to deal with this excess runoff. So what we end up seeing is a significant reduction in water infiltration, and we see an increase in that water runoff. And what this has led to is roughly $9 billion of urban flooding annually in the U.S., and just from the stormwater runoff alone. There's also the ecological impact, and what's happening is all these natural bodies of water are becoming significantly damaged due to the polluted runoff. So the question from here is, how do we fix this? So the U.S. government has acknowledged that there is a problem. What they've done is establish regulations for the Clean Water Act, requiring municipalities and counties to have programs in place to support this, whether it's MS4 permitting or just regulations through the Clean Water Act itself. However, there are challenges that exist within these regulations, and that challenge is that the government didn't align a sustainable funding source to these regulations. So it's estimated that there's $67.2 billion needed over the next 20 years to be able to sustain the stormwater infrastructure across the country. So there are loan programs out there, and there are tons of grants, but those are kind of good for the one-offs. They're good for today, they'll help you tomorrow, but 5, 10, 15 years down the line, these grants won't be there to sustain you. And roughly 2,000 municipalities across the US have integrated a stormwater utility fee to support these efforts. And 60% of them indicated the biggest challenge was the lack of sustainable funding. And this is why they introduced the stormwater utility fee within their communities. So let's talk about what Detroit is doing. So Detroit is an older city, which in turn, means their infrastructure is obviously very dated. And more recently, the city has tried to revitalize the likes of green infrastructure, modern infrastructure, but also long-term goals of making themselves a more ecologically friendly city. So they've been supporting their communities with investments to mitigate the effects of stormwater runoff. And with that, they established a stormwater utility fee to be able to fund these initiatives. So Detroit started off this program with a heads-up digitization approach. They contracted a company that came in and they manually digitized all the impervious surfaces across the city. So at first, this was working great. They had this data set, they had this fund that they can now fix other different infrastructure with. However, in year 2, when they went to update that data set, they started to run into some large issues. And this is where Ecopia comes into play in terms of supporting municipalities as they engage in building out these stormwater utility fees. And in 2019, Ecopia was awarded a contract from the city of Detroit to deliver plan and metric level data of impervious surfaces, which started off as a 12-layer land cover map and eventually transitioned into a 25-layer land cover map to not only support the water and sewage department, but citywide. So let's dive into this a little bit. So when we talk about data creation and supporting these stormwater utility fees, it's important to understand exactly how fast our communities are evolving. And when thinking about Detroit, the evolution represents about a 2% change in impervious surfaces year over year. So that's new in Detroit. So how do we go about making sure that, when you update these data sets, that you're seeing consistency? So this starts right from the beginning. You need to define the scope of impervious surfaces. What are you delineating? Is it sidewalks, driveways, properties at the residential, commercial level? Whatever it may be, it's important to understand exactly how you want that done. That's one thing that's very important to us here at Ecopia, is working with our clients to make sure there's not only a plan on building out what they want, building out a plan for that, the updates in the future, because that's arguably the most important part. So when creating these impervious surface data sets, it's important to understand and follow these 3 steps. So step 1 is defining the scope. Step 2 is identifying the features to extract. And then finally, step 3 is just creating that maintenance plan for the future. So heads-up digitization as it stands is a very manual and tedious process. So when we look at what the city of Detroit was dealing with that original methodology, they'd be getting their data sets back between 14 to 18 months after that aerial imagery was processed and delivered. So they'd basically be billing constituents on a 2-year-old data set. And, if you have that 2% delta of impervious surfaces changing year over year, there's going to be a few angry people across the city, when those bills aren't lining up. And that's the number one problem that communities face when integrating a stormwater utility fee is that public transparency aspect. So with Detroit coming to Ecopia, one of the primary things they wanted to see was a reduction in that time frame. And because of our semi-automated data extraction process, we were able to deliver the data set in that 4 weeks while also maintaining that high quality accuracy that they desired. So it's really important to understand 4 key points as we talk about data integration and build out. So those 4 pillars are flexibility, updates, optimization, and feedback. And then those 4 pillars kind of fit into these 3 stages here. So stage 1 is collecting. So we want to define the scope of work, collect the relevant data and extract the data in a format that enables updating year over year. Stage 2 is integrating that data. So we want to ensure that we're optimizing the resources you guys have at hand, combine it with other relevant information such as parcel data, right-of-way data, and any other existing vector layers that you guys might have already created. And then lastly, stage 3 is just to be able to maintain that data set. So we want to align with your goals and ensure that we have a set update schedule. We want to make sure this is a simple and repeatable approach for consistency and reliability purposes. So heads up digitization as it stands, very manual and tedious process. So when we look at what the city of Detroit was dealing with that original methodology, getting that data back 14 to 18 months after it was processed and delivered, was a tumultuous task for them, and it needed to be brought down. Also uncovering hidden money. So impervious surface changed at an average rate of 2% a year, and that equated to $5.6 million in discrepancies for the stormwater utility fee. So this is an example of the imagery that Detroit provided. This was near map imagery. This is just kind of your standard 1-layer impervious map that a lot of municipalities leverage. And this is what the city of Detroit was working with. later on. So they started off with a 12-layer land cover map that was a bit more basic than this, kind of just had your impervious features. And then once other departments kind of saw the use cases for these data sets, they wanted to get involved as well. And from there, they kind of evolved into more of the natural features. You can see the unpaved features as well. But yeah, that's what they're working with now. So as we kind of leave the city of Detroit case study, we're going to kind of transition into some more climate resilience topics. So what is a climate resiliency strategy? So climate resilience strategy can be kind of broken down by these 6 points. So assessing climate risks and vulnerabilities, developing adaptation plans, building resilient infrastructure, protecting ecosystems, enhancing community resilience, and investing in research and development. So I leveraged my good friend ChatGPT to help me to further define, what climate resiliency is. And this is what it had to say. So climate resiliency strategy refers to a comprehension and integrated set of actions, policies, and measures designed to help individuals, communities, and ecosystems adapt to withstand the impacts of climate change. It involves a proactive planning, risk assessment, and management aimed at enhancing the capacity of natural and human systems to cope with the changing climate conditions. So I would like to thank ChatGPT for that. And now we're going to kind of break down these 6 points and kind of fit them into several different use cases. So to kick things off, so stormwater infrastructure management. So the city of Jacksonville has long relied on geospatial analytics for stormwater decision-making. The Public Works Department leverages land cover data for not only planning and monitoring stormwater infrastructure, but also for determining stormwater utility fees that help fund the maintenance of this infrastructure. So the city found that keeping their maps and data up to date was a time-consuming, expensive manual process. And because they were dealing with over 360,000 parcels of land, this is a very time-consuming task. So by partnering with Ecopia, the city was able to procure 21 layers of high precision pervious and impervious land cover data in just 4 weeks, all for 84% less than the cost of a similar data offering. So now the Department of Public Works has a reliable source of truth for land cover and can spend time on actual analysis and planning instead of tedious manual feature digitization. So the next kind of use case here we're going to look at is the coastal land cover change detection. So the National Oceanic and Atmospheric Administration, NOAA for short, their Office for Coastal Management is responsible for supporting the environmental, social, and economic well-being of the U.S. coast by linking information, people, and technology. So the agency's Digital Coast website facilitates their mission by providing land cover data to communities and organizations to leverage their geospatial analysis. So keeping data up to date and with a changing environment is critical in all locations, but especially in coastal communities that are increasingly susceptible to natural disasters. So to equip these communities with the data needed for actionable stormwater analysis, NOAA provides high precision land cover data through their Digital Coast website. So while 10 to 30 meter resolution data sets were helpful for understanding land cover at a high level, NOAA partnered with Ecopia to produce a layer of 1 meter resolution data for increased granularity. So with this more detailed data, coastal communities can better detect change in land cover and develop hazard mitigation strategies based on up-to-date, high-precision information. So optimizing stormwater utility fees. So this is kind of touching on the Detroit use case, but another municipality relying on impervious surface mapping for critical workflows is the city of Detroit. The city redevelops their existing landscape to transition to more green infrastructure, while calculating those stormwater utility fees accurately is a key element to funding various public works projects. Calculating these stormwater utility fees requires accurate, up-to-date, and comprehensive land cover data that the city struggled to maintain manually in a rapidly changing world. Like other cities around the world, the city of Detroit partners with Ecopia to extract high-precision land cover data from geospatial imagery and create an annually updated source of truth for impervious surfaces to use in that stormwater utility fee calculation. So through this partnership and Ecopia's standardized methodology for detecting and mapping change year over year, the city can confidently analyze changes in impervious surfaces over time to optimize stormwater utility fees. From there, predicting stormwater effects with flood models. So flood modeling is a key component of the City of Peterborough's stormwater management strategy. So following a bad flood in 2004, the city has doubled down on leveraging geospatial data and mapping analysis to understand land cover's impact on flooding and better prepare for future stormwater events. So like other municipalities worldwide, the city struggled with maintaining an up-to-date, detailed, and accurate data set in the ever-changing world. So by partnering with Ecopia and consulting firm Jacobs, the city was able to deliver an integrated flood model from one consistent source of land cover data. And this is continually updated, and IFM is there to reflect that real-world change. So the IFM, powered by a 2D surface mesh of Ecopia's land cover data, is a critical tool for the city to forecast future flooding scenarios, prioritize stormwater infrastructure projects, and ultimately foster a more resilient community. So green infrastructure and stormwater planning. So having a high precision land cover database can help communities develop innovative solutions for stormwater management that also have other benefits for both the environment and residents. So for example, the City of Los Angeles partners with Ecopia to optimize the placement of stormwater medians throughout the city's extensive transportation network. Specifically, the City of Los Angeles Bureau of Street Services leverages Ecopia's provided traffic median, tree canopy, street tree, bus pad, and highlighted speed bump data in their mapping workflows. So these layers help the city identify ideal locations for medians that only help with traffic flow, but also convey water for stormwater management purposes and serve as functional green spaces, fostering a more livable community for its residents. So tree canopy analysis for flood management. So the Southeast Michigan Council of Governments, SEMCOG, also uses Ecopia land cover data for multi-purpose mapping projects related to climate resilience, as well as stormwater management. So spanning a 7-county region, SEMCOG oversees geospatial projects related to green infrastructure planning, pedestrian safety, and traffic engineering, as well as stormwater and flood management. So after successfully partnering with Ecopia on a transportation project, mapping more than 24,000 linear miles of sidewalks, crosswalks to understand accessibility in the region, SEMCOG expanded the relationship to include land cover data for stormwater mapping. So now SEMCOG utilizes map layers of buildings, sidewalks, driveways, roads, parking lots, railways, pavement, grass, bare land, tree canopy, and bodies of water, digitized by Ecopia. So these high precision map layers enable stormwater stakeholders to better understand land cover in the area and its impact on future flooding scenarios. And then lastly here, just to kind of wrap it up, sustainability decision-making. So King County, Washington is another example of a government applying comprehensive, accurate, and up-to-date land cover data for their public sector decision-making. So to avoid using piecemeal data sets of varying quality and vintage, the King County GIS Center partnered with Ecopia to extract reliable and up-to-date data, land cover data across more than 2,300 square miles of area of interest. So in just under 8 weeks, Ecopia provided King County with 16 planimetric level land cover data layers representing all natural and impervious surfaces. So the data supports a variety of initiatives across the county, including enhanced flood modeling, risk assessment, more accurate, timely stormwater assessments, wildlife restoration programs, as well as strategic climate action plans. Additionally, the data is being used to support transportation planning as well as social justice projects, ultimately helping the county improve day-to-day life for its residents. And with that, I'm going to wrap things up. If you guys have any questions, send them in the chat. But I appreciate you all taking some time out of your day to chat with Harneet and I.
Perfect. Thank you, Justin. Now we've got a couple of questions, and I want to touch upon the results for the polls as well. So thank you, everyone, for answering those questions. We asked you about the biggest challenges you have about geospatial data. And again, Justin, I'm going to come back to you for this as well. So people are talked about the biggest challenge most people voted on is incomplete data and the challenges with inaccuracy and sourcing the right data. So I know you talked about in the starting part of your slides about accuracy and comprehensiveness. Can you touch upon a little bit about how Ecopia can help municipalities get the right data, but also get complete data and in the timelines they want?
Yeah. So, every project is unique in itself. Some municipalities need that data faster than 4 weeks. Some municipalities need it a little bit further out. But that's the name of the game, and there's lots of flexibilities, working with us, whether it's the layers that you want to see, whether it's the timeline, whether it's an update schedule. We are very flexible with that. So there's lots of options out there.
Perfect. Okay, one question Scott has asked, and I can probably answer that if you want to jump in, feel free to. The question is about the Australian building extract you showed, I think back from 2017, and the question is, was near map imagery used for the Australian building extract, or was that sourced with Aerometrics stereo imagery? Thank you, Scott, for your question. That if you're referring to the project in 2017 done for PSMA in Australia, formerly known as PSMA, it's now called Geoscape, I think. That project was done using Maxar's imagery, not near map. So that's your answer for that question. But as I think Justin mentioned, we work with a lot of imagery providers. And Justin, can you talk about the imagery question as well? Because we often get this question from municipalities about them having the images or we providing that. Can you talk about that as well?
Yep. So we can kind of go down two different paths when it comes to imagery. So a lot of municipalities already leverage, that subscription to somebody, say like a near map. So if you have that imagery, then we can extract off of that. However, some municipalities don't have those subscriptions, so we can go out and source that imagery. So we have a relationship with Nearmap, Hexagon, and Vexel to have their newest imagery off the shelf. So for this year, we have all the 2023 stuff, and then they will be flying the 2024 in spring, probably in around March and April of next year. But yeah, if you guys don't have the imagery or you don't have the most up-to-date imagery, then we're more than happy to rely on our partner network to provide that imagery.
And does the customer have to buy that separately, or we can just kind of package that in our project?
Yeah, so we can just package that in. Again, there's kind of two paths to go down there. When it comes to the imagery, you can either buy the imagery outright, so you can own it, which is a much more expensive route, or you can just purchase the imagery for the extraction, which is kind of the way that most people kind of go about it. But yeah.
Awesome, thank you. I'm going to quickly ask you to touch upon, I think you talked about NOAA's project in terms of coastal change detection, a very prestigious project Ecopia worked on and currently works on with NOAA as well. So Nick Ho is asking, will you be discussing pricing and which product NOAA is using?
Yeah, so pricing. So this is a fun one. So the way our pricing is kind of built out is based on building density and area. So we don't have just like that kind of standard tiered pricing. Everything is kind of like on a project to project basis. So the way we kind of get those numbers is via a shapefile of the AOI. So from there, we could rip the buildings and the area from it, and then we put it into our pricing model, and we can kind of go from there.
Okay.
As for, sorry.
Go ahead.
And then I was just say, as for the NOAA deliverable, that's an ongoing project that we've been working with NOAA for the past few years now. So it's over 1 million square miles of data, and it is delivered. It is a free product that will be delivered on the website that I mentioned. I can put that in the chat actually. And it's a 1 meter product. Some states you get almost the entire state. Some states it's just about half. But yeah, that is a publicly viewable product.
Awesome. Thank you. Thanks for answering that. And Nick, if you have any more questions about the pricing, specifically for a project you're thinking about, we welcome you to get in touch. You can always email justin@ecopiatech.com, and we can take that forward. I've got another question here if you want to talk about Michelle's question about extracting objects such as buildings from the imagery data. How do you handle parts of objects covered by tree or building shadows? So, situation where we have difficulty in accessing those features.
Yep. So the first kind of half of that question, so objects covered by trees. So the way that we kind of go about that or get around it is, so all AI is just math. It's just probabilities. So when thinking about that tree canopy, say we have a sidewalk and the tree canopy, covers some of that sidewalk. The AI is able to figure out where, it is a straight line, and they can figure out where point A is and where point B is, and it's going to connect in the middle. So for use cases like that, where it's, a little bit easier, I guess you could say, with the tree canopy covering the sidewalk or the corner of a building, those ones are, the easy ones that we're able to kind of work through. And then there are some more unique cases where, you have houses that are completely covered by trees. Those are a little bit more tricky, and a bit more manual process has to go into those. But for those high tree canopy areas, when we're doing the QA, QC at the end, the AI automatically kind of brings the human in the loop to those high probability areas of errors. And then that's where the kind of human comes in, checks them out. And then the human also knows areas that, the AI has run into problems in the past, like tree canopy areas. So we're able to kind of go in and fix those up. But tree canopy has become a big product of ours. It is leveraged by countless numbers of groups. But yeah, we've become very good at tree canopy mapping. It is, when we deliver these products, tree canopy is delivered as its own layer. So you can kind of toggle it on and off. You can still get those impervious calculations, but you still get the full tree canopy layer.
Awesome. Thank you for that, Justin. I know we're almost at time, so I'm going to quickly ask you one last question, and then anybody else who has a question can always get in touch with us. We would definitely review this recording. If you had any other question, we'll reach out to you separately. Michelle says thank you. Thanks, Michelle, for joining us. Justin, the last question for you is again from Scott. And Scott's asking, my organization has an agreement with Nearmap, which provides us with access to a service of acquisition 3 times per year. May your post process be applied to historical acquisitions, looking for higher frequency derived data?
Yep. So we can do a lot of so short answer, yes. We can do an extraction from pretty much any imagery. So that's not a problem. I'm just rereading your question here. May your process be applied? Yeah. So the historical kind of acquisitions like that, a lot of times people will leverage kind of that question, I guess, when we're doing change detection. So a lot of the times, if a municipality has that vintages going back 10 years of that imagery, then we can go in and we can kind of create a change detection product from that vintage imagery. So yeah, we don't need to extract off of the 2023. We can extract off of, imagery from the 60s or the 70s or the mid 2000s, whatever it might be. The input, yeah, as long as there's some sort of imagery there, we're able to delineate different features or create that change detection product. But yeah.
Awesome. Thank you so much, Justin, for answering that. And Nick's asking for the NOAA site, but definitely we'll send that post the webinar as well. So I really want to take this moment to thank everybody who showed up live to this webinar. We really appreciate you taking the time off. If you have any feedback, use the emojis or reply to our post-event survey. Thank you so much again for joining. Thank you, Justin, for taking the time out of your schedule to do this. Really appreciate it. And anybody else has a question, please be in touch with Ecopia. Our website's www.ecopia.ai. We welcome your questions there as well. Thank you so much for joining us. And with this, we will be ending this webinar today and hope to see you on a future event of ours. Thank you so much.